Welcome back. We're in part 2 of points, lines, and planes. On the screen before you, you have your homework answers to last night's part 1. So look through those answers, see if you have any questions. I will point out a couple things, though, that these are just sample answers. Remember that you can name things in a lot of different ways, so these are just some sample answers. For instance, plane ABC, that could be plane BCA on your piece of paper. So just keep that in mind. These are just sample answers. They may not be the exact answers you have. So if you do have any questions or you want to check anything, please come see me. But moving on today, still talking about points, lines, and planes, but we're going to move into a little bit more algebra today, and we're going to talk about the segment addition, postulate, and midpoint. Now, before we get started here, we need to know what a postulate is. First off, a postulate is just a statement that is accepted as true without any proof. We've actually talked about a couple postulates in yesterday's video. In fact, I'll roll it back here for a second. These 5 little things right here were postulates themselves. Again, something that's accepted as true without really any proof. Some of them are really kind of common sense. Same thing here when we talk about the segment addition postulate, which says that if A, B, and C are collinear points, meaning they're on the same line, and B is between A and C. By the way, I'm going to add a little extra thing here. If you ever see the word between, that's literally telling you that they are collinear. And if B is between A and C, then you could say AB this section plus BC this section equals the entire length AC. And that's the segment addition postulate. Again, pretty common sense there. But we're going to do a few examples. So for the first example, point B is on line segment AC. In fact, I'm going to use this picture right above here for this problem. And they want to know, what is the length of AB if AC is 22? So I'm going to say, okay, this whole line is 22 units long. BC is 13. We want to know what AB is. I'm going to call that X, since currently I don't know what it is. And using our segment addition postulate, AB, which we called X, plus BC, which we called 13, equals AC, which was 22. And we're just going to do a little algebra here. Subtract 13 on both sides, and we will get X is equal to 9. Meaning our answer to this problem, AB, is also 9. And I want to point out something really specific here. Notice I did not put the line segment over top of AB. And that's because if we're talking about a numerical value, then you don't need to put the line segment over top, because that would mean you're talking about the picture. And we're talking about its numerical value, not the picture here. So AB is equal to 9 is how you want to write that answer. Let's do another one. Let's look at that second example. Use the figure to solve for X. So here we go. We've got, in this problem, 5X plus RS, which is X minus 8, equals PS, the entire length of the segment, 52. And we can do a little algebra here. 5x plus x, combine our like terms to make 6x minus 8 equals 52. Add 8 to both sides. We've got 6x equals 60. And then divide by 6, you get x equals 10. And that's what they wanted to know on this problem. They want to know what x equals, so x equals 10. Again, we solved that through the segment addition postulate. Remember, a postulate is something is accepted as true without any proof. So moving on. I've got 4 examples on this page. You are more than welcome to work them out if you'd like. I'm going to write the answers here, so if you'd like to work them out and try them beforehand, go ahead and hit the pause button, because here come the answers. For the first answer, AB would be equal to 2.6. In example number 2, RT would be equal to 70. Remember that you're looking for RT here and not necessarily X, so make sure you're reading what the question's asking. Number 1, or example number 1 here, find YZ. That would be 1 2/3 if you left it as a mixed number. I would also accept 1.6 repeating, or if you really wanted to get fancy, you could write 5/3. Lastly, number 2 here, DF would come out to be 24. So hopefully you did pretty well in those examples there, following the segment addition postulate. Moving on here, adding some more stuff for this lesson. We've got something called congruent segments. The word congruent literally means the same. So two segments that have the same length, we call those congruent segments. This is the congruent symbol. It's an equal sign with a little wavy line over top. So in this scenario here, a lot of times they mark congruent segments with something called tick marks. They'll write these little things, and that's just a visual way to say, hey, these two things are the exact same size. So PQ, RS would be the exact same size there. In fact, we could even write that out. If we wanted to use our congruent symbol, we could say PQ, line segment over top, is congruent to RS or SR. They're both exactly the same, so it doesn't really matter the order. We use the congruent symbol when we are talking about pictures. So in this scenario, you'll notice I have the lines over top when I use the congruent sign because we're talking about pictures. Earlier, when we were doing that very first example, I didn't put the picture over top because we were talking about the numerical value there. We weren't talking about the picture, we were talking about its length. So something really kind of specific to pay attention to. Another word you need to know, the word bisect. That is going to come up a lot this year. And it means to divide a figure into two congruent parts. So for instance, in my little picture over here, B is a bisecting point, sometimes referred to as the midpoint, which we're going to cover here in a second. But you'll notice we have 3 units on the left, 3 units on the right. So B is a bisecting point there. It literally bisects that line into two congruent parts, which is what I have written up here. AB is congruent to BC. Normally we don't call it a bisecting point, we'll just call it a midpoint, but you get the idea of bisect means to cut something into two congruent parts, whether that be lines, angles, whatever it will be. So going on to use midpoint, we're still going to be using that segment addition postulate, but we're going to mix it in with some midpoints. So in this first scenario, B is the midpoint of AC, and when they tell me that, I'm going to put tick marks on there. It's a really good visual way. I would encourage you to do it as well, just to say, hey, these two parts are the exact same. And they want us to find AB, BC, and of course AC. So I'm not going to add these together like I did in those last couple problems because I don't know what the length of the entire segment is. So what I'm going to do in this case, since I know they are exactly the same, I'm actually going to just set 5x equal to 3x plus 4 and figure out what x is. So if we subtract 3x, we get 2x equals 4, which means x would be 2. Now I can figure out that AB is 10, which is our first answer we're looking for. Notice I did not put the line over top of AB because we're talking about its numerical value. BC should also be equal to 10 since we said they were the exact same. You can also check 3 times 2 is 6. 6 plus 4 is 10. So BC, second answer, is also 10, which would make our whole line AC. Now we can use segment addition postulate. 10 plus 10 equals 20. We'll do one more of these together. So this one, there's no picture drawn for this, so you may want to draw your own picture. S is the midpoint of segment RT. So this will be my RT. S is the midpoint. I'm going to throw in tick marks just to visually say those two parts are congruent. RS is negative 2x. ST is negative 3x minus 2. And since I know they are exactly the same, I'm going to set those equal to each other. So negative 2x is equal to negative 3x minus 2. Add 3x, you do get x equals negative 2. Now that's not an answer we're looking for. Remember, we're looking for RS. So now that I plug that back in, we got negative 2 times negative 2, which is positive 4. So RS is a length of 4. ST should be the exact same 4, but you can plug it in if you'd like. Negative 3 times negative 2 is positive 6. 6 minus 2 is 4. And then lastly, add our segments together to get the full segment. That's your segment addition postulate. 4 plus 4 is 8. So that's using midpoint along with segment addition postulate. We can do some more on that. These are a little bit more challenging. This one has meters and kilometers, so even to start this problem, you need to know that 1 kilometer is equal to 1,000 meters. That way you're working in the same unit. So maybe instead of writing 2 kilometers here, we might write 2,000 meters. And if you read the instructions, it says the map shows the route for a race. You are 365 meters from drink station R and 2 kilometers from drink station S. The first aid station is located at the midpoint of the 2 drink stations. And again, tick mark, visual way for you to know those are congruent. That is the midpoint. They want to know how far are we away from the first aid station. Well, this is going to do some segment addition. First off, if I do XR plus segment RS, that should equal segment XS. Now, they already told us what XR was. It was 365. RS, we don't know, so for right now, I'm just going to leave that as RS. And XS, I know, is 2,000 kilometers. And if we subtract 365 from 2,000, we get 1,635. So now I figured out RS is 1,635 meters. And since Y is the midpoint, if I take that 1635 and divide it into 2 equal parts, I'll know that each section is 817.5 meters. So now to finish the question, how far are you from the first aid station? Another segment addition problem, XR plus RY, that's the distance X to Y, which is how far we are away from the first aid station. XR, remember, was 365. We know now that RY is 817.5. And if we add those together, we can figure out what XY is, which is the distance we're looking for. 365 plus 817.5 is a total of 1,182.5 meters for XY. Just how far away we are. Now, because we did all that math for the first problem, the second question here gets a little bit easier. It says, what's the distance to a drink station located at the midpoint between your current location and the first aid station? So I'm going to change colors here. So we're looking for the distance to a drink station located at the midpoint between our current location X and the first aid location Y. So between X and Y, we want to find where is that midpoint. Now, we know that the distance to the first aid station is 1,182.5. So if I want to find the midpoint between that, I can take 1,182.5. I can divide that by 2. And we would know that that distance is 591.25 meters away. Which means it's about going to fall right in here somewhere. That's about where another drink station is located. Last thing for today, midpoint formula. So we talked about what a midpoint is. Now we want to do it with a little bit more of a two-dimensional look to it. So like if we had 2 coordinates on a coordinate plane, we could find the midpoint. And this is the formula right here. It's actually a really easy formula to follow. You're going to have 2 points, let's say A and B, coordinate point. And all you're going to do is average the x coordinates and average the y coordinates. So what I mean by that is add your x's together, divide by 2. You'll add your y's together, divide by 2, and that will be your midpoint. So for instance, let's do an example here. Given the point, in fact, you know what I'm going to do? I'm going to draw a little coordinate plane just to kind of demonstrate this. Let's get a little color here. So we're going to draw a little coordinate plane. And it says given the points A at -3, 2. So left 3 up 2, that's about where A is at. A, -3, 2. B is at 5, 2, so go right 5 and up 2. That's a nice horizontal line. So there's A to B. We want to find the midpoint of that. Find the midpoint of AB and the midpoint of CD. We'll get to CD next. So if I'm averaging the x's, I'm going to take -3 plus 5. Those are the two x values. Divide those by 2. Add my two y values, which are both 2, divided by 2. And the midpoint, which I'm going to call m, -3 plus 5 is 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And our final answer would be 1, 2. About right there. That would be our midpoint m, 1, 2. Changing colors now, let's move over to red. C is at 1, 1, so we'll say C is about right there, 1, 1. D is at 1, 7, so straight up. Makes a nice little vertical line there. Again, a little bit more practice here. Average your x's, average your y's, so midpoint is CD. 1 plus 1 divided by 2. And my two y's, 7 plus 1 divided by 2. We've got 2 over 2 and 8 over 2. So our final answer for midpoint there would be 1, 4. It's about right there. 1, 4. And that's how you found midpoint on a coordinate plane. Now it does ask a separate question here. It says, do the segments intersect at one of the midpoints? And they actually do. They intersect at the blue midpoint right here, which I'll highlight in green. They actually cross right there at 1, 2. So in essence, segment CD bisects segment AB. Bisect meaning it cuts in half segment AB. It goes right through the midpoint of segment AB. If you'd like to try this on your own, here's another example. This one takes a little bit more to it, but we'll go through it together. It says if CD has an endpoint at 4, -6, and you know what, for this one, I actually will make another coordinate plane just to kind of demonstrate one more time here. So C has an endpoint at 4, -6. I'm thinking, okay, to the right 4, down 6, that's about where C's at. Now this time they tell us the midpoint. The midpoint is -2, 6. That's where the midpoint is. So if you're thinking, where are the other coordinates of D? Well, if M is the midpoint, I'm thinking D has got to be up here somewhere. Now this takes a little bit more thinking to it. Okay, we're still going to use the midpoint formula though. Okay, so take a look. We got our midpoint formula. This would be our x1, y1. I don't know my x2, y2. I don't know what they are. We don't know where D's at. I'm just going to fill it in with x2, y2 for now. But I know that they're going to average out to be my midpoint. So let's see. I'm going to go ahead. 4 plus whatever that x2 is divided by 2. And we also have -6 plus whatever y2 is divided by 2. But I know what the answer is going to work out to be. I know eventually the answer is going to work out to be -2, 6. I know that because that's the midpoint. They gave me the answer to this. So what we got to figure out is, what does that x2, y2 need to be so that I get that answer? So for instance, let's look at just this section right here. Let's look at just this. What number divided by 2 would give me -2? At least that's what I think in my mind. I'm thinking, okay, what number? I don't know what this is going to be because I don't know what x2 is. But what divided by 2 is going to give me -2? And the answer to that would be -4. -4 divided by 2. So my question would be, how can I make that 4 plus x2 equal -4? What would I have to add? What would x2 have to be? And the answer is it would have to be -8. So my x2 is going to be -8. And I'm going to do the same thing with this fraction. What number divided by 2 is going to give me 6? Well, 12 divided by 2 is going to give me 6. Well, how do I make -6 plus y2 equal to 12? Well, if you add 6 to both sides, you get y2 equals 18. So y2 must be 18. Meaning, what's the coordinate point for D that we didn't know? it's -8, +18, which if you look at my picture, over 8 and up 18 seems to be pretty accurate. And that's your answer there. So you can do this if they give you the midpoint as well. It takes a little bit more thought to it, but you can do that as well. And that really kind of wraps up the lesson for today on midpoint and segment addition postulate. And we will move on to a brand new lesson tomorrow. Make sure you do your homework. Bring any questions you have tomorrow.